Hello, and welcome to Engineering Ethics at NJIT. This is March 21st. It's the Tuesday after spring break. So welcome back, everyone. We are in lesson 9 of the course. So let me jump into the Moodle just to orient us. So we're in lesson 9. The topic this week is climate change and geoengineering. I put the videos up online this weekend for the lecture. Oops, let me change it. Sorry. There, okay. Good. Okay, so we're on lesson 9. This is climate change and geoengineering. I put the lectures up this weekend so you can watch the lectures, participate in the discussion. Some people have already started grading. Let me just remind you of a couple of housekeeping things about the assignments in the course. So the first thing to say is that the replies for lesson 8 will be due tonight. So lesson 8 was due the week before spring break on the Deepwater Horizon. So you had to turn in your post for that on the Friday before spring break. But the replies for this lesson will be due tonight on the 21st. So you still have time. If you didn't do the replies before, most of you did, but if you hadn't already, you can still do those replies for full credit. That also means that your late posts for lesson 8 will also be due this week. So if you turn in your post, if you didn't turn in your post on time, you can still turn it in up until this Friday for late credit. This week's climate change and geoengineering, I give a little lecture online about temperature and about the challenges of geoengineering. And then the other big thing I want to mention is that next week is your research project week. So this is lesson 10 and 11. You're required to do your own library research on a case study of your own choosing. I've also put up the lecture for lessons 10 and 11. It's the same lecture for lesson 10 and 11. And the lecture is really just me going over the requirements for this assignment. So the video is pretty short. It's less than half an hour. And it goes through this slideshow that you can also walk through. There's no new lectures for lesson 10 and 11. I will have Hangouts for both next week and lesson 11, week 11, at the normal time on Tuesdays. And we can talk about your research projects. If you have any questions about your sources or anything like that, we can talk about those during those Hangouts. So one more time, lesson 10 and 11, which is next week and the week after, you're required to do a research project on a case of your own choosing. You have to do library research and put together an annotated bibliography. And the posts are also longer than normal. They're about twice as long as normal. So, or I'm sorry, about 50% longer than normal. So a normal post should be at least 400 words. And for lessons 10 and 11, the posts are required to be 600 words or more as a minimum requirement. They're also worth twice as much. And instead of a quiz, you have to do the annotated bibliography. So that's coming up next week and the week after. This week, just to get you back coming off of break, we're going to do some more stuff on climate change and geoengineering. Let me go ahead and pause there, just so we've caught up, and let me see if there's any questions or thoughts anyone has. Let me open it up to the group. If you want to just leave a question in chat, that'll also work. Any questions? No questions? Oh, someone's writing a question? Okay. Yeah, so Bara asks if there's a specific list of topics to choose for the research projects. Good question. So the topic can be any topic of your choosing. My suggestion is that you pick a topic that's on some case that's relevant to your own career goals. So If you're a mechanical engineer, maybe pick a mechanical engineering sort of case. Or if you're a chemical engineer, pick a chemical engineering sort of case. If you're not an engineer, pick a case that's relevant to your own field. And if you're still not sure about what field you're going into, then try to pick a case that you think you might run into no matter where you go. So I want to leave it open-ended so that you can explore some case that'll be relevant to your own career path. Will the library have anything for game development? Absolutely, and in fact, there's a lot of discussion, ongoing discussion about game development and ethics. As games have been getting bigger and more public, more activity, the issues of ethics and abuse for something like Pokemon Go, people getting mugged from playing Pokemon Go, all those things have spawned a lot of ethical discussion, and you'll definitely find things about game development and ethics. Let me write a name. I just put Ian Begosh in the chat. He's a good source to look for game development and ethics. Yeah, so that's a perfect example of a kind of topic that, if that's what your interests are, then do some research and find a good case of ethics in that field. The trick to making a good project, having a good presentation, is finding good sources. So don't just pick a case that you're interested in, but pick a case that you're interested in and that you find that you have a bunch of good sources to draw from. I don't want you to just quote the sources or summarize the sources. The point is not just to do a book report, although you might want to put some of that stuff in the annotated bibliography. But the point is to take those sources and compile a story of what happened in the case so you can explain it to the other students in class. Yeah, you know what? I'm going to put another link in the chat here. I just watched an excellent talk on game development and ethics from a few weeks ago at the GDC. So one of I think he was the developer for EverQuest back in the day. He talks a lot about developing AR and VR worlds that are ethical. And this talk I just posted in the chat. It's very good. Ralph Koster. Oh, I'm sorry. He designed Ultima Online back in the day. Okay. Yeah. So game development is a great source for ethical questions. Another thing that we've talked about in class that might be somewhat relevant to your career are lists of whistleblowers or cases of whistleblowing. So I talked last time we met. I talked about the Uber whistleblowing on sexual harassment that has been going around social media recently. And that's it's an interesting case. It might be relevant to your career. It might be the sort of industry that you're looking to get into. I give a bunch of examples of case studies on the Moodle page, and in particular, I give some Wikipedia pages that list major disasters, major structural failures, key engineering ethics cases, and lists of whistleblowers. But you should not treat this list as comprehensive. If you find another case that you want to talk about, that you want to spend a few days researching and thinking about, please do. Are there any other questions about the upcoming research project? Again, this is due not this week, but next week. So we'll have at least one more Hangout where you can come ask questions. But you should really be thinking about, at least be picking a case this week and starting to do some preliminary research. One more housekeeping thing that I should mention is, as far as I know, the extra credit essays from section 458 are the only things that I haven't graded. I did most of the grading over spring break and this weekend, so up till this weekend. So anything posted yesterday or today in the last few hours, I haven't graded. But all previous assignments that I know about, including all the quizzes, except for the extra credit assignments for section 458, I think I've graded everything else. If that's not the case, if you know that you have assignments that haven't been graded, or if you've sent me a note from the dean and I haven't excused those late or missed assignments, if there's any grade issue that you have with me, please send me an email, let me know. even if you've already sent me an email before, so right now I'm considering myself, apart from these extra credit assignments, I'm considering myself sort of fully graded. So if you know of something that I haven't graded, please send me an email to remind me. Rosanna asks in the chat, can we still post extra credit essays even though it's due on 310 for late points? Yes, yes you can. So the policy is that if you posted it on time, the first extra credit assignment was worth 20 points, and if you post late, you can still do the late post and it'll be worth 15 points maximum. So you lose 5 extra credit points. You can also leave replies in the extra credit form, and I'm grading the replies for 10 points each. And that's going to be graded separately from your regular reply requirement. So don't, if you leave replies there, that's fine, but just make sure you also leave your weekly replies as normal. So yes, so Bara, yes, you still can submit the first extra credit essay for reduced credit. I'm giving a little bit of a bonus to the people who did it on time, but it's a good assignment, the ethics of your field. And so if you still want to do that assignment, you can still get extra credit. There's one more extra credit assignment. I think it just opened up and it'll be due at the end of the semester. The first extra credit assignment will also be due on the last day of class. And there's another extra credit assignment I just put up on intellectual property rights and piracy. So if you want to do that extra credit assignment, you can also do that up until the last day of class. Remember, I give lots of extra credit partly because I feel like I grade the forms somewhat harshly. So hopefully that'll balance it out in the end. Any other questions about the assignment structure, about upcoming due dates, about grading? I believe I've graded all the old quizzes that I had to do by hand. I think all the quizzes that are coming up will be multiple choice questions. And if you haven't looked ahead in the syllabus, after the research project in weeks 10 and 11, lessons 12, 13, and 14 are going to be on artificial intelligence. Lesson 12 is just a sort of introduction to artificial intelligence and the philosophy of artificial intelligence. Lesson 2 is about AI in our social spaces, including war machines. We'll talk about killer robots and drones. And then lesson 14 is about the economic impact of robots taking our jobs. Lesson 15, you will also have an assignment to post. That's the last week of the course, but it'll just be what did you learn from the class? What were your favorite assignments? What are you coming away from this course having learned? So there's no additional lesson for week 15. And then that's the final assignment. There's no final after that. In boating school, I learned. That's nice. Okay, so if you have any other questions about the assignment structure or the lesson plan, oh, it's the SpongeBob lessons. Okay, so I'm sorry, I'm too old for SpongeBob. Okay, so if there's any other questions, go ahead and interrupt me in chat or send me an email. If there's any grading that you know that I haven't finished, remind me by email and I'll get on top of it. And unless I hear from you in the next couple of weeks, I'm going to assume that everything is everything's okay. I do know that the last day to withdraw. The last day to withdraw from the course is next Monday. So if you're not doing well in the course, if you've missed a significant amount of the assignments in the course, because of the late policy, you won't be able to make up old assignments. So this is your last chance to evaluate your standing in the course if you want to go through with the course, or if you want to withdraw and try to take it again in a future semester. I'll remind you that the grading rubric on the syllabus is that the lowest passing grade is a 50%. Let me go down to the bottom here. So it's somewhat difficult to get an A over 90% because the way that I grade pushes grades to a B. So you have to do extra work, either extra credit or really go above and beyond in your assignments to get an A. But the low end is also clipped, so you can pass the class with 50% or 800 total points. If you want to know about your standing in class right now, Oh, one more thing I should mention. The attendance quizzes have been a nightmare this semester, and it's completely my fault. I think I might have mentioned this in a previous week, but what I did is I duplicated the quiz for each assignment, and that it doesn't just create a copy of that quiz, but it actually repeats that same quiz. So when you make changes to the quiz, like changes to the answers, then it changes it for all previous quizzes. And that's been a nightmare. And it's all sort of messed up on the gradebook. If it confuses you, I apologize. It's confusing me also. The thing you need to know so that it's not confusing is how to calculate your final grades. And that's really just a matter of adding up all the points that you have. So there's no special weighting on Moodle. One point is worth 1 point no matter where it appears on the grade sheet. So don't look at the percentage, don't look at the final percentage, because that's not going to be correct. What you want to do is you want to calculate up your total points and then compare that to the final grade scale in the syllabus. And that'll tell you what your standing is in the class. Right now we're in lesson 9. So we've had 800, and there's about 100 points a week. So we've had about 800 points turned in so far. That means that you should know if you're passing the class by now or not. And then you can use the scale to figure out your standing. Okay. So that's basically all I want to talk about today. I was thinking about saying a few things about geoengineering to the students who have watched the lecture, maybe watched John's lecture. But I don't, maybe I'll just open it up to questions. If anyone has any questions about the stuff I talked about climate change in the lecture or any of the geoengineering stuff. The big thing, if you haven't watched the video lecture yet, the big thing that I do, is go through this temperature website. So this is a website of one of my friends, John Baez, who's a mathematician at University of California, Riverside. And he gave, on his homepage, he has this sort of history of temperature on the planet. A lot of it's just links to papers, but there's all these really cool charts that talk about temperature over the last 4.6 billion years. And so you can see how temperature has fluctuated, and you can put the current magnitude of climate change in some perspective. So the planet has been around for 4.6 billion years. This is the whole history of the planet, from warm on this side to cold on this side. And you can see that at some points it's been really, really warm. When the Earth started, it was a big molten ball of rock. But then it fluctuates back and forth, and it doesn't do it in any easy pattern. This is a very complex process that fluctuates almost randomly, it seems. It's not exactly random. We know that there's a lot of influences on it, and we have gotten really good over the last few decades of measuring these. But I mean, one thing becomes very clear is that right now, it's not the warmest it's ever been on the planet. In fact, it's been much, much warmer during the period of the dinosaurs. It was significantly warmer than it is now. But during the period of Homo sapiens, during the time that human beings have been alive, it's been relatively cool on the planet. So this is the last 65 million years. 65 million years ago was when the dinosaurs died out. So this is like the reign of mammals you're seeing here. Even during the reign of mammals, it was warmer than it is now. But the really important thing is not just how hot or cold it is in some absolute sense, but really how stable it is. So you can see there's this little period of stability here, where temperature still fluctuates, but within a relatively narrow range. And that period of time lasted 10 million years. Pretty good. If you don't know your history of anthropology, the primates have only been around maybe 20, 30 million years, so around this last time period. Homo sapiens have only been around maybe 200,000 years. And we've only been behaviorally modern for maybe 70 or 80,000 years. Anthropologists talk about behavioral modernity as not just when we're anatomically human. So we've been anatomically humans. There have been human beings anatomically identical to you and me walking on the planet for a few 100,000 years. But in terms of culture and tool sophistication, we've been behaviorally modern for maybe 80,000 years, maybe a little bit longer than that. That means we've had tools, we've had languages, we adorn our bodies in jewelry and clothes and control fire. we start domesticating dogs and so on. For the last several tens of thousands of years. My favorite chart in this whole set, though, is this one, the Younger Dryas. And I just want to talk about it for a little bit because I like it so much. So human beings have been around for tens of thousands of years, but we've only been, for hundreds of thousands of years, we've only been behaviorally modern for like 80,000 years, but we've only been agricultural, sort of civilized humans, civilized, as they say, humans, for about the last 10,000 years. Before 10,000 years ago, we were hunter-gatherers. You couldn't settle in any one place because the temperature fluctuated too wildly, and so we sort of wandered the earth. It was over that time period that we populated every continent on the planet except Antarctica. But we did it as a sort of nomadic lifestyle, moving around, because things would get hot and then they would get very cold. The last ice age was the Younger Dryas, happened around 12,000 years ago. Before that, there were still saber-toothed tigers and woolly mammoths and so on. There was still a land bridge you could cross between Asia and the Americas, which we did. And then there was this ice age. After that ice age, the woolly mammoths and the saber-toothed tigers die off, and things get somewhat warmer. But for the last 10,000 years, they've been incredibly stable, more stable than they've been at any point in our human history. And all of everything you know about human history, everything you know about human social systems happens in this time period, right? Every government, every culture, every religion, every tradition, every myth was developed over this last 10,000 years. The last 10,000 years where the climate has been stable enough to support agriculture and the rapid expansion of human populations. So before this time, human beings numbered at most a few million across the entire planet. And then the climate gets warm and stabilizes, and we can start planting crops, we can start domesticating agricultural animals, and we built huge civilizations, and the human population balloons to, what now, 7 billion people. And all of that growth happens because the climate became very stable. And that period of climate stability is over. No question about it that this period of climate stability is over. The amount of carbon in the atmosphere is more carbon than has been seen at any point in human history. And in fact, anytime in the last several million years, you don't see these kinds of climate conditions at any point where human beings have been on the planet. The only time you see human civilization develop and prosper is in these periods of abnormal climate stability, and we've done very good at mucking that up. So climate stability is over. We're going to have to learn again to deal with a planet with radically fluctuating climate. We've done it before as human beings. We've lived through we've lived through time periods with dramatic temperature changes, but we were also much fewer in number. We didn't live in giant cities, right? We had to move around all the time, that kind of stuff. We didn't have corn or wheat, right? Things were different. So the change in temperature, the change in climate systems, it's not just that things are getting warmer, but things are getting unstable, right? So we're having blizzards in March and so on. It is a nice way to spend spring break, stuck indoors during a blizzard. But this is the kind of instability that results from changes in global climate, and we don't know how to deal with it. So part of the challenge here is it's not just a technological or engineering challenge. In a theoretical way, we know how to deal with it. The challenge is really a political challenge, an organizational challenge, right? How do we get people to do all the things we know we need to do? And scientists have been talking about climate change for decades now, and we still are nowhere near a position where we're able to deal with it. And it's just going to get worse. We're looking at possibly 6 degrees centigrade change in temperature, in average temperature, by the end of the century. That's in your lifetimes and probably your children, probably your lifetimes and definitely your children's lifetime. So this isn't some far distant sort of science fiction future dystopia. This is the world we live in today. And because it's gotten so scary, the prospect of engineering on global scales becomes a live possibility. I mean, in some sense, the change in climate is a result of our engineering behavior, but it wasn't deliberate. It was sort of an accident, unfortunate byproduct of what we've done. And people have been proposing deliberate attempts at engineering the climate system to get the climate stabilized, or at least back within what's comfortable for human beings. And by comfortable, I mean not just that it feels nice, but that we can grow crops that we need to survive, and so on. Right? Because 6 degrees centigrade change, our crops won't work anymore. Right? If humans don't have access to corn and wheat, we're going to be in a lot of problems. So I wanted to say just a little bit about the carbon cycle, and then talk about aerosol injections, which are the most popular kind of geoengineering technique that's proposed. But let me stop before I say anything about this and see if anyone has any questions or thoughts or comments from the chat. I know climate change is sort of the popular topic nowadays, especially on campus like this. I'm sure you get lots of discussions in your classes about the importance of climate change, the difficulty in dealing with it. I mean, part of the reason that you hear being talked about so much is because it really is the challenge of your generation, and it's part of the responsibility of your generation to figure out some way of dealing with it. Not because it's your fault, but because you're going to be the ones in charge when all this stuff comes crashing down. So people are talking to you about climate change a lot because it's going to be very important in your future. So I don't mean to just drone on about something that you've heard lectures on a lot. Hopefully I'm trying to teach you something new about the history of temperature so you can contextualize how dramatic of a situation we're in. Literally something that's not seen in recorded human history. We don't have any memory of how to deal with climates that change this dramatically. Right? Like I said, every religion, every tradition, every myth, everything we have written down, right, every story that we have comes from the time period where the climate has been very stable. So human beings are going to have to learn again. So is it true that geoengineering will always be a temporary solution? That's a great question. That's a great question. So most of the proposals for geoengineering are temporary solutions. They're not meant to last a long time. So the aerosol injections are supposed to be the clearest example of this. So the idea of an aerosol injection is that you take some natural greenhouse gas like sulfur dioxide and pump it into the high atmosphere. And the idea is that you block out some of the sunlight before it actually gets to the surface so that you cool things down. And this is a temporary measure because all that sulfur is going to fall out of the sky eventually. And part of the challenge of this kind of technique is that when it falls out of the sky, it falls out as acid rain. And that acid rain not only has a bad impact on the planet's surface for all the life on planet, yeah, and in the ocean. But the acid rain also causes droughts, yeah, so that makes it not good for any living things on the ocean. So if all the sulfur falls out, that means you have to sort of inject more sulfur, and the idea is you do it every couple of years. And so the one worry about aerosol injections like this is that it becomes addictive. That what you're doing is you're really just buying a sort of credit extension. This it's not a solution to climate change, but it buys us a couple more years by cooling down the planet just a little bit. There's a bunch of comments in chat. So Smith says that people have now become aware of this problem and there are now innovations taking place in the field. Yeah, that's right. Scientists, I think, have been aware of this for a few decades now, since the 70s, but it hasn't really trickled out into the public consciousness until the last maybe decade, maybe 2 decades. And that's really because the change has become apparent from just looking outside. Right? You ask anyone over 40 if they remember weather like this. This is not normal. So Rosanna says, can cities become unlivable if nothing is done about climate change? Because I heard cities like Abu Dhabi could have intense heat waves that could prevent people from being able to live there anymore towards the end of the century. That's right. I mean, we're already seeing temperatures, like absurdly high temperatures in deserts. Let me see if I can find the record is right now. I want to say it was in 134 degrees in Death Valley. And sometimes with, yeah, I mean, it depends on the way that you measure temperature. If you include the sort of ambient heat generated by that temperature, it could get even hotter, right? Like if you're standing over concrete or standing over asphalt on a very hot day, it's going to be even hotter. Or if you're in a big desert where it's all the sand radiating back at you, it can be even hotter, right? So, and these absurdly high temperatures will just get more absurd. This is definitely going to make some places of the planet inhabitable. I mean, there are already places of the planet that are inhabitable because of extreme weather, and there are places on the planet now that are currently populated that won't be habitable by the end of the century. The biggest discussion of this kind of stuff is with sea level rising and the way it's going to affect coastal properties. So the lower end of Manhattan will probably be underwater by the end of the century. But the thing is that there's a lot of money in the lower end of Manhattan, right? That's where the financial district is. That's where Wall Street is. That's where all the money is. And so they'll probably spend lots and lots of money to keep Manhattan afloat, right? To build like levees and dams to make sure the water doesn't come onto the island. But other towns that aren't as wealthy, especially in Florida and the Gulf states, when those places go underwater, that's just the end of that town, and people just have to start moving, and they have to start moving now. And again, this isn't even for the places that haven't had the sea levels rise to the point where it's impacted the local populations. It's already making an economic impact. So, for instance, it's really hard to get homeowners insurance in some places in Florida because the insurance companies know that those regions will be at threat of flooding in the next few decades, and that's the time period that these insurance policies last. And so they're already thinking about this. So it's already becoming an economic issue, a business issue, a planning issue. So Bara asks, do you think we're ethically obligated to take action against climate change, even if the government is making it nearly impossible for environmentally focused organizations to thrive and make progress? It's an excellent question. So this is part of the challenge of the time, right? So the big point I want to make is that it's not just an engineering challenge. It's not just a technical challenge. If it was just the technology, then we have plenty of solutions on the table for dealing with climate change. The real problem is a political problem, is getting these technologies in a position where they can actually do work. So let me go back to the aerosol injections. You have to release a lot of sulfur dioxide in the atmosphere for this to have an impact, like on the order of teragrams. 5 to 7 teragrams every year. That's a lot of sulfur dioxide. It would be a very expensive project, but relatively expensive. So like Facebook and Google both have high altitude blimp projects that they're using for Wi-Fi and like weather monitoring and so on. You can imagine some dystopian scenario where the government is not funding any environmental protection services, and a company like Google or Apple or Facebook decides to take it in their own hands and send a blimp up to the sky and place a bunch of sulfur in the atmosphere. So obviously this would be illegal. It would go against a bunch of environmental regulations. But the challenge here is that this is the kind of thing that a single actor can do without a whole lot of support, right? So I was talking about corporations doing it, but imagine some country does it, or imagine China does it, and imagine that it has negative impacts, right? So it causes a bunch of acid rain damage or droughts or so on, right? So part of the challenge here is that we don't have any global governing framework for making these kinds of decisions, or for addressing unilateral actors who put the planet at risk, right? We don't have any procedure for systematically organizing not only the actions themselves, but policing those actions, responding to those actions, regulating those actions. We lack we lack the human organization systems for managing these things at scale. And that's really scary because a unilateral actor can take an action like this and can have planetary significance. So the computer models suggest that if you actually dump a bunch of sulfur dioxide in the atmosphere, you really do get cooling. You really do get some cooling. So in this chart you see on the top, if we do nothing and how much temperature change, which is nothing. But if you release a bunch of sulfur dioxide in the upper atmosphere around the equator, then you do get significant cooling relative to doing nothing. The problem is that it doesn't last for very long. You have to do it every couple of years, and it has all these other environmental damages, impact. I guess, let me actually go through the questions. So, are we ethically obligated to take action? Right, so if Facebook decides that they're ethically obligated to do something like an aerosol injection, I mean, it's a really scary proposal because we don't know how to manage such a thing. Same thing for individuals. One non-aerosol kind of engineering attempt that John talks about in this talk is seeding the oceans. So the ocean is a major, so it's a major place where carbon gets taken up out of the atmosphere, out of the water, and it gets taken up by the life forms that sort of float in the ocean. And so the idea is that if you encourage these life forms to bloom, right, to reproduce, then maybe they'll pull more oxygen out of the atmosphere. And it turns out that the big constraint on these life forms flourishing is iron. Right, they lack iron. So the idea is that if you put a bunch of iron in the ocean, then maybe it'll produce a bunch more organisms, and those organisms will pull more carbon out of the atmosphere, and then we'll have less global warming. So this is just a theory, really, and I mean, there have been tests of it. There haven't been any large-scale tests to see if it would work on a global scale. But there have been cases, and John talks about it in this talk, where someone just decides to test it for themselves. They go out in a boat into the ocean, dump a bunch of iron in the ocean to see what the impact it has. Again, these things are illegal. They get stopped by the EPA, but it's the kind of thing that an individual could do of their own initiative, and especially a well-funded individual like a corporation could do of their own initiative. And we don't have a lot of resources for stopping this or regulating it. In fact, most of the institutions we have don't prevent these systems from working, but they actually encourage them, right? We saw this with Deepwater Horizon. I mean, in some sense, BP in these massive oil drilling expeditions are doing large-scale engineering efforts that have global impact, right? Deepwater Horizon definitely had a global impact. And the government doesn't successfully stop these corporations from having this impact, but in fact, it encourages them to have it and gives them an incredible amount of power to do what they want. So you can imagine a unilateral actor taking some action that has this sort of global impact. This kind of stuff is worrying. Well, let me go through. There's a lot more comments. They're good. So I read on Facebook about a small intervention some engineers developed. Some engineers developed a pen whose ink is produced from the glass released by cars. 45 minutes of emission produces around 30 milliliters of ink. That's pretty cool. Imran Rashid says, climate has always changed before the discussion of pollution. What would be the permanent solution to fix or resist a rapid climate change? People can't keep cutting back, especially since population is growing. Well, I mean, so one thing to say is that if you look at natural systems, you don't just have growth to stability. What you have is growth to overgrowth, and then pruning back until it finds a stable place, right? So you have sort of overgrowth and then a pruning back until it finds a stable point sort of along that curve. So like, the deer population explodes, and then there's not enough food to feed all the deer, and so a lot of the deer die away from starvation, and then it really reaches a happy balance. The deer population exploding might be happy for the deers, but the aftermath of that, right, the reset to balance, is not very happy for the deers at all, right? Having a bunch of deer without food, it's a bad thing. So this is what human beings aren't. It's not that we're not going to have food, but we're not going to be able to manage a global population at scale. it's not going to be good for human beings. A lot of people are going to die. People are already dying from climate change. There's been some discussion of current political chaos, partly being a product of climate-induced, right? So all the immigration that's happening in Europe right now is partly a result of this the civil war in Syria, but that's partly a result of massive droughts in the region that have pushed a lot of farmers out of their farmland and disrupt the political stability. And right, so the disruption of the economic stability of human beings disrupts the political stability, and you get political chaos. Right, we're living through the very start of this political chaos, and it's very unlikely to stabilize because we don't know how to stabilize it. We don't have any systems to stabilize it, so it's only going to get worse. But so Enron says that climate has always changed even before the discussion of pollution. That's right, and if you look at the history of temperature, climate has changed far more radically over the course of the history of the planet than we're seeing right now. The important thing, though, is that the way the climate changing is outside of the bounds of human experience. So over our evolutionary history as human beings, we've never seen climate change this rapidly. The temperature on the planet is intimately connected with the life forms that can live on the planet. When the planet was very hot, you had a bunch of big dinosaurs and a bunch of big insects and so on. You needed a warm climate to support those big animals. Now it's relatively cooler, and you have the mammals. Some mammals are pretty big, but most of them are fairly small. Human beings aren't that big. And it's partly related to the cooler climate, right? So if we're out of a stable climate period, that's going to change the kind of things we can do, the kind of crops we can grow, the kind of lifestyle we can live. So Emron says that people can't keep cutting back. Well, I mean, nature might force us to cut back. It might cut back for us. So it says there's no going back from this changed weather. So the only way is trying to reduce the change and develop technologies that provide comfort in these conditions. Yeah, I mean, I think developing technologies that provide comfort in these conditions is part of the challenge. I mean, you might worry that if it forces us to all live in caves underground, how comfortable will that be? But I think it's not just developing the technologies that provide comfort. I think it's also developing the social systems that can manage population scale decisions, that can manage collective organization at large scales. Right? We don't have those social systems. Right? We don't have the political infrastructure necessary to make decisions. Right? So if we just give us a bunch of comfort technologies, it would be comfort technologies as sort of end of life care for species extinction. Okay, so there's a bunch of messages. This is good. I'm just going to read off a bunch of messages. Okay, so isn't most of Hoboken on top of water? I know the soccer field becomes entirely flooded when it rains heavy. Yeah, I mean, New Jersey's basically swampland. And you can look online for charts about how sea level rise affects, actually, let me read off the rest of the comments because there's a whole lot of them, and then I'll see if I can find that sea level rise. Trump did reduce the EPA funding in his budget plan. Yeah, that's right. He's threatened to cut EPA funding. Another thing that he's cut is NASA. So a lot of the data that we have, a lot of the satellites that we operate that monitor the climate systems come from NASA. So NASA does a lot of the climate modeling science, and Trump did a huge cut to NASA funding for climate science. Right, so he's cut off the very tools that we have for understanding the situation that we're in, which makes it very unlikely that we're going to be able to fix it. Oh, so there's a lot of discussion of Trump. So Trump did reduce, yes, anything he plans to end it altogether. I mean, his administration requested EPA take down this climate change page on the website, which didn't help. I remember somewhere that those pages are all just a blog of the record, the current president's actions, achievements since Obama. Yeah, since Obama is no longer the president, they took down the records, and then he cut NASA and NOAA funding. That's right. Yeah, and I mean, he's cutting science, and I mean, this is what authoritarians do when they get in power. They clamp down on the media, control the media. They control all the science and education, all the intellectual heads. And so the population has no resources from which to resist. We were in a bad situation. I mean, in complete fairness, Hillary Clinton recognized climate change as a serious problem and made lots of pledges to do something about it. But those pledges were sort of in line with the sort of rest of the planet, and the rest of the planet is not on top of climate change either, right? So having Clinton in position would put us in it would put us at least in a better position that we're not cutting all these government agencies, but we still wouldn't be on top of climate change. One of the scariest things that I put in the Moodle lecture is this climate change calculator from the Paris conference. So this is looking at where we are now and what we're looking at given the agreements that were made in Paris. So I think in 2015, a bunch of countries and big businesses and so on gathered in Paris for this major climate change conference where all the major countries made pledges about the future of climate change and how they were going to deal with climate change in their own country. So China, US, EU. So if we do nothing, if we do nothing at all about our current situation, we are on track for 6 degrees centigrade climate change, 6 degrees Celsius climate change by the end of the century. 6 degrees Celsius is, we're talking crop failures and major disruption to our way of living. So all the countries come to this conference to make pledges. These are non-binding pledges. There's no penalty for not following through with these pledges. But here are the pledges they made. So by 2030, here are the cuts that each of these countries are pledging to make. If we keep to these pledges, which again, remember, are non-binding, there's no penalty for not keeping these pledges. But if we keep to the pledges that we're making, we're looking at 5 degrees centigrade change by the end of the century. That's still really bad news. Since the 70s, when scientists were talking about climate change, their threshold for serious concern was 2 degrees. If we ever cross that 2 degrees centigrade threshold, then things become so unstable that we won't be able to manage them. In some limited sense, we've already passed some cases of 2 degrees centigrade change, but there's no possibility of us staying below 2 degrees centigrade now. The hope is that we stay somewhat far away from 6 degrees, that we can stay around 2 degrees, but the pledges that we're making aren't getting us there, right? All of the pledges that we're currently making still put us at 5 degrees centigrade. Right, so these are the pledges that these countries have pledged to make by 2050. Again, non-binding pledges. There's no guarantee that we're going to keep these pledges, but even if we do keep them, we're still looking at 4 degrees centigrade by the end of the century. Right, so with someone like Trump in charge who's actively hostile to climate change, this is just going to get worse. But even for the people who recognize that climate change is an issue, we're still not where we need to be. Right, the idea that we just need to make technologies to keep us comfortable. It sounds like end of life care. Right, this, when your grandparents have some terminal illness that they're not going to recover from, and you just want to make sure that the end of their life is comfortable, right? They're happy for their last few remaining months or whatever. That's fine, but for a human being, that's maybe ideal for a human being, but for a species, that's different. That we would be recommending end-of-life care for humanity as a species. It's a very scary prospect, and we don't have a lot of good signs that say that we're going to get out of this. This is why things like geoengineering become live options, because there are no other good options on the table, but we know how to build blimps and pump a bunch of gas up into the upper atmosphere. Right? We know how to do that. Maybe it won't fix things. In fact, maybe it'll make things worse, but at least it's something we know how to do, and so we don't feel just completely helpless. Where are those aerosols? Yeah. Another reason we look at these aerosols is because we have actual models of what happens when something like this takes place. So in 1991, Mount Pinatubo was a big volcano that erupted. Depending on the kind of volcano, they tend to have a lot of sulfur in there, in the plumes of smoke. And Mount Pinatubo released on the order of the kind of sulfur dioxide in the upper atmosphere that we would expect to be doing with aerosol injection. So we can actually study, what happened after Pinatubo, and see what it means for us. So it did result in a change in temperature around the globe. It also resulted in massive droughts for several years after Mount Pinatubo explosion, and those droughts were concentrated around the equatorial regions where the volcano was. So you do get cooling, some cooling, but you also get these significant droughts. And importantly, these droughts affect the planet disproportionately. It affects some places more than others. And in fact, the places that it affects most are also the places that are economically and socially least equipped to deal with the challenges of something like a massive drought, right? The equatorial regions concentrate some of the largest populations, but also have some of the least well-developed social and political infrastructure for dealing with, for managing the populations, and especially in a sort of global crisis or environmental crisis. This is going to be a source of major human tragedy. And again, we don't have the political infrastructure for making a decision like this that will affect the planet disproportionately. Right? The UN, and it's a deliberative body, but it's certainly not effectively managing global climate change. So what do we do about this? There's a couple of other strategies for geoengineering. The most promising one from a safety standpoint is carbon sequestration. Carbon sequestration is where you find chemical means of pulling carbon, so not biological means, but chemical means of pulling carbon out of the atmosphere. If you can sweep a net across the sky and pull out a bunch of carbon, that would be carbon dioxide. That would be great. And there's ways of doing this that are promising, but they're also very slow and expensive. And so you need access to the right resources. So there's lots of attempts of chemical carbon sequestration in places where there's cheap and reliable geothermal energy. For instance, in Northern Europe, they have lots of geothermal energy, sort of easily available geothermal energy, which is very cheap and easy to use. And you can use that to do this carbon sequestration. You don't want to burn fossil fuels to do it, because then that would defeat the purpose. So you need lots of cheap energy in order to do something like this, and it's very slow. But this is one of the regions where technologies might help. I want to show this chart at the very end, just to wrap this up. Yeah, this chart. So this chart is, there's nothing over here. It's just a comparison of some of the kinds of geoengineering techniques in terms of how affordable are they. So the higher here, the more affordable they are, the better that is. And then how effective they are. So the higher this is, the more effective they are. The most affordable and the most effective and the safest is afforestation. In other words, planting a bunch of trees. Trees take out a bunch of carbon from the atmosphere. If you plant more green stuff, you get stability of the climate. So it's cheap. It's cheap and it's effective, but it's also relatively slow. I'm sorry, it's cheap. It's not very effective. It's relatively slow, but it's a relatively easy thing to do. The next most affordable on this list is the stratospheric aerosols that I've been talking about. The reason that it's so attractive is partially because it's so affordable. It's relatively cheap to do. And because it's cheap, that means someone is likely to try to do it, or is likely to at least be interested in doing it. But it's also very dangerous. It's very difficult to control the effects. And it's purely temporary, right? So that's not, I mean, this is for you to decide. Write your post this week about one of these techniques. And whether you think it's a good idea, whether you think it's ever a good idea to be attempting to manipulate the global climate on global scales. Yeah, Bloopy says, in nature there already exists ways to clean the environment, for instance. It's not a SpongeBob reference. There already exists ways to clean the environment. For example, a plot of trees absorbs tons of carbon dioxide, but we can keep destroying most of our rainforests. I mean, yeah, that's right. Afforestation, if you keep planting trees, that'll take carbon out of the atmosphere. It's the most environmentally sound way of doing it. It's also fairly slow, and it's not, doesn't make a lot of money, right? It's fairly cheap, but it's also not a cash guzzler. Injecting stratospheric aerosols, you need blimp pilots, you need engineers to build the blimps, you need to get all that sulfur, right? And that's an industry, right? And that's going to support a bunch of jobs and so on, right? So that's why, and this is part of the affordability. This is why it's attractive, and this is part of the ethical challenge: is weighing the attractiveness of such an option against its ethics, or whether it's actually the right thing to do. And part of the challenge is that as these climate events get more and more extreme, right? As we see more extremely damaging hurricanes and droughts and this kind of stuff, the more extreme weather events we see, the more there will be public cries to do something about it, and the more attractive these cheap and dangerous solutions will be. At least we're doing something, people will say, as the world burns. Okay, are there any last questions? I think I've done I said everything I want to say. It's been an hour. Are there any last questions or comments or thoughts about climate change, geoengineering, or any of the assignment structure? Oh, the secret word. I didn't mention it today. The thing I was gonna make the secret word albedo. So let me make the secret word albedo. So the Hangout secret word is albedo, ALBEDO. Is it there on the screen? Oh, sorry. Let me share the screen again. Yeah. Surface albedo. So albedo is the reflectivity of a surface. So something with very high albedo is very reflective. It reflects most of the light. And something very low albedo is absorbs light. So asphalt in an urban area absorbs lots of light and energy, and it retains that heat. This is why cities are always a little bit warmer than the surrounding countryside, right? It's because cities are made with concrete and asphalt. That stuff absorbs sunlight and retains it, and so the cities stay a little bit hotter. So albedo is another one of the ways of geoengineering that's been suggested, is adjusting the surface albedo. The biggest impact of surface albedo are the ice caps. So ice is white. White is very high reflectivity, and having lots of ice on the planet's surface reflects a lot of the light away and keeps the temperature stable. This is why it's so important that the polar ice cap is melting. This is one of the things that's leading to a lot of the climate instability. The destabilization is partly the result of no more polar ice cap, and so a lot more energy being absorbed, and so so all the ice melts and things are destable. So a solution to this is to build a bunch of surface reflectors. One proposal, a very expensive, probably very stupid proposal, is to cover the Sahara Desert in mirrors. If you just build a bunch of mirrors in the Sahara and point them in the sky to reflect all the light away, that way it's not absorbing all the heat. And the thing is, again, we don't know what impact this will have at a global scale. Will you kill off, will it destroy the environments there? Will it, maybe burn the ozone layer? Who knows what? Yeah, or solar panels, right? So solar panels won't reflect the light, but it'll absorb the energy and change it into something that we can use, right? That might also be useful. So here it's important to remember that Sahara, it's a desert, but it's also a living ecosystem. There's lizards and snakes and some plants and so on that live in the Sahara. So if we cover it all over with solar panels or mirrors, you might destroy those those ecosystems. If it's mirrors, you might cook birds that fly over them or something. These kind of things you don't know. Another big problem with doing something like this, so it'd be very expensive to build a bunch of mirrors or build a bunch of solar panels. Elon Musk keeps talking that you could fill, a small square of Utah, 30 miles of Utah with solar panels and supply the entire United States with cheap solar energy from just that little square of solar panels in Utah. But so the solar panels would be useful. If you were to build mirrors, part of the challenge is it would be very expensive to build, but then if it didn't work, it would also be very expensive to take all that equipment down, right? And no one would want to do it if it didn't work. No one would want to put in the extra money to take it all down. So these are the kind of things that are part of the challenge. This is why albedo isn't talked about so much in things like carbon sequestration, aerosols, talked about a lot more. Yeah, so albedo is the secret word for the Hangout. I think the quizzes don't have this up yet, so I'll just, what if we just played glitter everywhere? I think that would go against the categorical imperative. All right, thank you everyone. If there's no more questions, I'll go ahead and end the Hangout today. Excellent questions. Thank you very much for the discussion. It's a good way to start class. Good luck on your assignments this week. Remember, you can turn in your replies tonight, and then good luck on your research project next week. I'll see everyone next week.